Alright, so we are looking now at linear systems and solving them by graphing. Alright, so here's a chart here just to kind of describe the differences in terminology that we use for different types of solutions. Today, well, in class we've been looking at if the lines intersect at one point, like they do here. So here they intersect at one point. That means it's got one solution, and that we also say that this system is consistent and independent. This one in the middle here, that actually looks like there's only one line, but that's actually when the lines are on top of each other. And if that happens, they intersect everywhere. So they have infinite solutions, and we say that this is consistent and dependent. On the far right here, the lines are parallel, and if the lines are parallel, they never meet. And if they never meet, they don't have any solutions. And we would say that this system is inconsistent. Okay, in this example here, we want to see if the ordered pair 5, 2 is a solution for the two equations. So what I'm going to do here is just take that point and plug it in. So the first 5 there is it represents x, and the 2 represents y. So I'm just going to take the equation, plug 5 in for x, plug 2 in for y, and see if that indeed makes a true statement. And 2 times 5 is 10, 3 times 2 is 6, 10 minus 6 is 4. Does 4 equal 4? Yes. So 5, 2 is a solution for the first equation, but now we want to also double check on the second. It's got to work for both of them. If it doesn't work for both of them, it's not a solution. So here we put in 2 times 5 plus 8 times 2 and see if that equals 11. Well, 2 times 5 is 10. 8 times 2 is 16. When you add 10 and 16 together, you get 26. Does that equal 11? It does not. This is not a solution. Here, hold on a second. Let me fix that real quick. Okay. Not a solution. Alright, so here I'm going to graph these two equations and look for a solution by if they intersect. So I'm going to do two different methods here. The first one in green here I'm actually going to do with slope-intercept form. If you get the y equals mx plus b, where, whatever's in the m is the slope. So slope equals m, and in this case m is 1. If you write that as rise over run, you get 1 over 1. The y-intercept, which is the b, in this case is also 1. So I'm going to graph the y-intercept, put a point at 1. Slope is up 1 over 1, up 1 over 1, up 1 over 1, and we can keep doing that, and then draw a line to go through those points. And then for the equation here, in black, y equals negative x plus 3, I'm going to do a t-chart. Refresh your memory on that. Let's pick some values for x. Say I use 0, 1, and 2. If I plug a 0 in for x, 0 plus 3 is 3. If I plug a 1 in there, that becomes, over here, that becomes negative 1 plus 3. Negative 1 plus 3 is 2. If I put a 2 in there, that gives me negative 2 plus 3, which is 1. And you see a pattern as x increases by 1, y decreases by 1. So if I put a 3 here, I would suspect that that would be 0. And if we graph those points, 0, 3, 1, 2, 2, 1, 3, 0, draw a line through them. Line's a little off there. Okay, and then look for where it intersects. And it looks like it intersects at the coordinate 1, 2. So just to double check it, I'm going to plug it into each of the equations. So if I look at the first one, and I plug in a 2 for y, a 1 in for x, does that give me a true statement? Does 2 equal 2? Yes, it does. And if I go to the other equation and plug 2 in for y and 1 in for x, does that give a true statement? Negative 1 plus 3 is 2. Does 2 equal 2? Yes. So it checks out. That's our answer. So here is the final.